Hello class, it's Mr. Calblin again, and I'm here to present lesson number 5 or 5.5 for chapter 5. And today's lesson will be dealing with what are called first differences. And it actually deals with a calculation that we're going to tie in the next lesson when it comes to slope or rate of change. So let's get right to it here. All right, so what first differences in are again? It's a calculation. However, I've kind of introduced you to this already in an earlier lesson. Back in earlier lessons, I keep asking you to see if you see a pattern in the numbers. Well, guess what? If you understand how to do that, then this will you'll quickly understand exactly what first differences are. And like I said, first differences is a type of calculation which is going to help you determine whether something is a line or not, as well as to find a way to determine or calculate slope using another method. But that's for the next lesson. But like I said, today's lesson will help you build that particular skill. All right, so what exactly are first differences? Well, when you're given a table of values like this, what first differences are, okay, are the differences between the y values. But before we do that, you always should double check to see if the x values here are all going up by the same amount here. So if you take a look at the x values over here, okay, notice that as we go from the top all the way to the bottom, each of these numbers are going up by 1. So as long as it's going up by a steady amount over here, or going up by the same amount, okay, then that tells you what we can do next here is to calculate the first differences, which are the differences of the y values here. Now, a couple of lessons ago, I keep mentioning pattern of numbers, and that's exactly what first differences are. So if you look at the y values over here and you notice, well, these numbers here are going up by 2. Well, guess what? Those are the first differences. Now, if you don't see that right away, or if the numbers are you can't see them right away, and you can't see the pattern right away, you can actually calculate that by subtracting what are called successive y values. And what that involves is taking the value and then from the value that you're looking at, and then you're subtracting it from the next one. So to find the first difference between 0 and 2, I'm just going to take 0 and then subtract it from the 2, just like what you see on the screen here. And that will give me here an answer of 2. Okay, same thing for this next one. I'm going to take this 2 and subtract it from 4, and surprise, surprise, that also gives me 2. So you can see here that all I'm doing here is I'm taking the value and then subtracting it from the next one. And as you can see, each one of these has an answer here of 2. Now, when you have first differences and they're all the same, okay, that tells you what you have here is a linear relationship. Now, what a linear relationship is, if you look at the word linear, that means if we were to draw this, you'd get a straight line. So anytime you look at first differences and all of them are the same, that automatically dead giveaway that what you have there is a linear relationship. Now, if you don't get that, okay, and you're going to see many examples of that in today's lesson, what you have here is what's called a non-linear relationship. So we're going to go through many examples today to help you understand the difference between the two. And basically, the only two things that you just need to remember for today's lesson are those two things that you see with the big fingers. All right. So again, we're going to calculate the first differences. If they're the same, they're linear. If they're not, they're non-linear. Okay, that's pretty much it. All right, let's take a look at some numbers. And again, I'm going to start off relatively simple first. So first chart, the first table of values over here. Okay, if you check the x values, you notice the x values here are going up by 1. So we're set to go here. So if you're looking down the values over here, 7, 3 to -1, -5, -9, okay, take a moment to look at to see if there's a pattern. Now, just as a reminder, not all the examples we're going to look at today will have a pattern. So don't automatically assume that when you take a look at the first set of numbers, that the numbers will be the same. Okay, so if you take a look down on the y column as you go from the top to the bottom, okay, some of you probably notice that each one of these numbers is going down by 4. Okay, if you got that, then that would be the first differences for this particular question. Now, if you didn't see that right away, that's okay. Okay, remember that what you can do here is to subtract the successive y values like this. So if I went 3 minus 7, okay, you notice that that will give me -4. As I mentioned just a few seconds ago, these numbers are going down by 4. So that's what the -4 represents here. All right, let's just double check the next one. So I'm going to take this 3 and then I'm going to subtract it from -1 like so. And sure enough, we get -4 there as well. All right. Now, I'm just going to do a quick reminder of what happens when you're subtracting a negative number. So what I'm going to do with this -1 is I'm going to subtract it from -5. Okay, so as you can see here, I'm subtracting a -1 from -5. And don't forget that anytime you see a negative, that's the same thing as adding. So what we have here is -5 plus 1, okay, which gives me -4. All right. And last but not least here, we're going to take the -5 and then subtract it from the -9. Okay. And that will also give us -4. Now, double check the numbers I have there on the far right hand side in red. And you notice that all of them are the same. Since all these numbers here are the same, this particular table of values will be linear. All right. Now, what I want you to do right now is to pause the video, okay? And I want you to work on the next questions. And again, first calculate the first differences, and then from there, based on the first differences, okay, determine whether it's linear or non-linear. So you only have two possible answers. All right, moving on to the next example over here. Just to double check, if you take a look at the x values, okay, you notice that each of these x values are going up at the same amount. Okay, always do just an informal check just to make sure that you do have that, because the only time you can calculate first differences properly is if the x values are going up by the same amount here. And in this case, we do. All right, for this one over here, okay, you can see that we're going from -3 to -1 to -1 to 3, and then 3 to 9, and then 9 to 17. As I mentioned in the previous example, don't automatically assume that there's a pattern for all the numbers that you see in a table of values. That's why in this particular situation, okay, you do need to look at every difference separately. Okay, some of you could probably see the difference just by looking at the numbers, but when in doubt, always subtract the successive y values. So for example, for the first difference here, okay, I'm going to take the -3, then subtract it from the -1 like so. All right, and just as another reminder, when you have two negatives, we have -1 plus 3, which gives me 2. All right, so the next one, you're going to see now, I'm going to take the -1 and then subtract it from 3, which changes itself to 3 plus 1. And you notice that this gives me 4. Now, I've only done the first two so far. Notice that already the first two differences are already different. Okay, so this should be a dead giveaway right now that this is not going to be a linear relationship. But let's just finish this question just to make sure. All right, this next one over here, if we take the 3 and subtract it from the 9, we get 6. And last but not least, we have 9 and 17. We're going to take the 9, subtract it from 17, and it gives me 8. So in this particular example, we have 4 different numbers. So since these numbers here are all different, okay, this tells us here that this particular table of values is non-linear. All right, so this is your first example of something that is non-linear. Now, we're not going to draw this for this particular lesson here, but if we were to draw this, you will see exactly what you have, and you actually have what's called a parabola, which is a U-shaped curve, which you're going to spend a lot of time on in grade 10, not in this course. All right, so just bear with me here. All right, let's take a look at the next example here. Okay. Double check here for the x values. We have -4, -1, 2, 5, and 8. Okay, just do a quick check here. These numbers here are going up at the same amount. Okay, they're all going up by 3. So for the first differences for these ones, again, exact same thing. Now, as you go down the y column, if you're really good at this, you should probably notice that all of these numbers here are going up by 5. Okay, but let's just double check that by subtracting the successive y values here. So we're going to take -10, subtract it from the -5 over here. And don't forget, when you subtract the negative, always change it to addition. Okay, so we have 5 there. We're going to take -5, subtract it from 0. And guess what? We get 5 there as well. All right, just to make sure, we get 5. And last but not least, we get 5. So notice that all numbers that we have here are 5. So since these are all the same or all constant, this particular table of values here will be linear. All right. So those are the basics of calculating first differences. Again, are the numbers the same? Yes or no? If they're the same, they're linear. If they're not the same, they're non-linear. All right, we're going to wrap this up here, and we're going to put everything together. We're going to construct a table of values using equations, and then from there do the exact same thing, calculate the first differences, Okay, and then from there determine whether we have something that's linear or non-linear. All right, so when you're looking at this question over here, what we have here is a table of values and an equation. And what we want to do here is to complete the table of values, okay, calculate the first differences, and determine if something is linear or non-linear. So what we're going to do for each one here is we're going to substitute each of these x values into the equation y equals 2x. So we're going to do this step by step for this one. All right, so step number one, we're going to take 0, and then we're going to substitute it in for the x. Okay, remember you can do this in your calculator using brackets. Okay, so when we do that, we'll get a y value there of 0. Same thing with 1. Okay, that will give me 2. And then when we get 2 and we put the 2 into brackets over here, that'll give me 4. All right, so notice what we have so far. Again, just to double check, notice that these numbers here, all we've done here is substitute these values in for the x, just like you see on the right-hand side there. So let's finish off the rest over here. And the reason why we can actually finish this particular question here is the fact that you should notice that there's already been a pattern with the numbers here. Now, if you saw the pattern to be that the numbers are going up by 2, guess what? You're already ahead of the game because those are the first differences there. So when you're looking at the first difference, okay, so just to double check, our first difference here is going to be 2. Our second difference here, first difference here is also going to be 2. So is our third, and last but not least, so is our fourth. So since all of the first differences are the same, okay, what we have here is a linear relationship. All right, so let's take a look at another one here. And just to double check, or just to make a note of the difference of the equations, notice what we have is y equals 2x. This one here is y equals x squared. So all we're going to do with each of these numbers is to substitute these numbers, put it in brackets, and then square it. And you can use that using the x squared key on your calculator here. So starting off with the first one, okay, that will give us 0 squared. And when you do that, that'll give me 0. Okay, next one here, we're going to take 1 squared. Okay, and that'll give me 1. Okay. Next one here is 2 squared, and that will give me 4. All right, now take a moment to do 3 squared and 4 squared. Okay, and if you do 3 squared, okay, you should get 9. Okay, because what you're doing there, remember that squaring a number is taking a number and just multiplying it by itself. Okay, and you should get 4 squared to be 16. All right. Now, if you take a look at these ones, I kept these numbers relatively simple just to get my point across over here. If you take a look at these numbers, notice that these numbers here are going up by a different amount each time. So from 0 to 1, okay, what we have here, the number is going up by 1. Now, before I proceed with the remaining steps here, these calculations of calculating the first differences, if you can do them just by looking at them, okay, it's not required for you to show these steps. This is just a demonstration for those people who want to see the calculation. All right, next one over here, we have 1 and 4. Okay, so you should know that to go from 1 to 4, you're going up by 3. Okay, so I'm just doing the calculation just to show you that. To go from 4 to 9, you're going up by 5. So you can see that in the calculation by subtraction of the successive y values as well. And last but not least here, 9 to 16, okay, goes up 7. And in this example over here, okay, notice that these ones over here are going up by a different amount. So that makes this non-linear. All right, so notice the first example, we had the equation y equals x squared, y equals x. This one here is y equals x squared. Our final one that we're going to look at over here is going to be y equals 2 raised to the exponent x. All right, now for this one over here, don't forget to raise a number by a certain exponent. You press the exponent key, which in the calculators in my class is that y to the tiny x key. In some calculators might be a little hat like this. Okay, in your if you have a cell phone calculator, you should have a little hat like that as well. Or some of them even have the big Y and the tiny x. Okay, so different phones will have a different function for exponents. All right, either way, let's just do the calculations over here. So for this one here, we have 2 to the exponent 0. Now, this is the first time you've seen this one, so you might be a little bit shocked in terms of what the answer is for this one. But anytime you take a number, and you raise it to the exponent 0, it's always going to give you an answer of 1 there. All right, so don't be too shocked when you see that in your calculator. All right, next one here, we're going to take 2 and raise it to the exponent 1. Okay, that's going to give me 2. Okay, this next one here, we're going to take 2 and we're going to raise it to the exponent 2 over here, and that gives me 4. All right, now take a look at this next one here. We're going to take the 2 and we're going to raise it to exponent 3. Okay, and you notice that that's going to give me 8. And last but not least here, when you go 2 to the exponent 4, that should give you 16 there. All right, so if you take a look at these numbers, notice that each one of these numbers, just like the previous one, are also going up by a different amount. So let's just go through the steps behind that. All right, so if you take a look at to go from 1 to 2, you should notice that it's going up by 1. Okay, so another way you can calculate that is to subtract the successive y values like so, by taking the 1 subtracted from the 2. Okay, gives me 1. To go from 2 to 4, it's going up by 2. So let's just check that, and sure enough, it does. To go from 4 to 8, it's going up by 4. Okay, not too shocking there. And to go from 8 to 16, you're going up by 8. All right, so if you take a look at these 4 numbers over here, okay, you notice that they are all different. So this here would also be an example of something that is non-linear. All right. All right, so just to summarize what we did today, and then I just want to just take a quick look, quick glance at the last 3 examples we did over here. So if you take a look at the last 3 examples, I'm just doing a quick snapshot of some of the things that we did over here. Just bear with me. So when you're looking at equations, common question is, how do we know just by looking at an equation whether something is linear or non-linear? And that's exactly what I'm going to show you here in just a moment over here. And basically, when you take a look at an equation, okay, you should be able to determine whether something is linear or non-linear over here. So, all right, so I'm just cutting and pasting here for a moment. Just bear with me over here. And basically what I want to do here is that when you take a look at a question, okay, or sorry, an equation, okay, just by looking at it, you should be able to figure out what type of relationship it is without even looking at the table of values here. And like I said, all I'm doing right now is I'm just cutting and pasting the equations from the last example just to get my point across here. All right. So if you take a look at my screen over here, okay, notice that what I have here on the screen in the blue, okay, are the 3 equations that we looked at in the previous example. So in the first example over here, y equals 2x, okay, remember what we had there was something that is linear. All right, so that was for the first equation there. Okay, this next one here, this y equals x squared, okay, sorry, what we would have there would be an example of something that is non-linear. All right, so that's for the second one. All right, and last but not least over here, this last one over here, this 2 to the exponent x, remember that 2 was non-linear. Now, take a moment before I throw up the answer over here. I want you to take a look at the 3 equations, okay? The first one, which was linear, the second one, which was non-linear, and this last one, which was also non-linear, okay? If you take a look at the 2 non-linear equations, ask yourself this question: what do these 2 equations have that this does not? Okay, Jeopardy song again. Do, 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 do. Oh, time's up. All right, if you take a look at the 2 nonlinear equations, okay, you notice that each one of them has an exponent. Okay, this one has an exponent 2, and this one over here, the x here, is the exponent which you replace with any number. So anytime you see an equation of an exponent of 2 or greater, okay, that will tell us something that that will tell you that what you have there is something that is non-linear. Okay, so anytime you have an equation and it's just an x on its own with the invisible 1, then that tells you what you have there is linear. So when you look at equations, always look at to see if you have any letters with exponents. Okay, anytime you see a letter with an exponent of 2 or greater, it is automatically non-linear. All right, that wraps up today's lesson. So continue on working on the review, and I'll see you in the next lesson.